Picking up with the example of sample variance and standard deviation. So let's see how you did. We want to first calculate the variance, so s squared, and we want to take the difference of each value from the mean. So we need the mean. So the mean in this case, you add them all up and divide by the total. So that ends up being, the sum is 7,092. Divide by 4 ends up being 1,773. So we need to subtract that from every observation in the data set squared. So 2398 subtract 1773 squared. Add it to the next one. 1844 subtract 1773 squared. Next one, 1539, whoops, don't want the bracket yet, subtract 1773 squared. And let's see if I can get this in. The last one is 1311, subtract 1773 squared. You want to take the sum of all those and divide by n minus 1, which will be 4 minus 1. That ends up being, and I hope you got this, it's going to be 663,866 divide by 3, and that ends up being 221,288.67. All right, so the standard deviation, or formally the sample standard deviation, if you want to really be super clear, is just the square root of the variance, the sample variance. All right, and that ends up being equal to 470.41. So what happened here is we ended up, if let's say these were all in dollars, then this would be dollars squared, and then the standard deviation would then bring it back to dollars. Okay, so this would be, if these were in dollars, the original data, this would be dollars squared, and then back to dollars. And that's one of the advantages of using the standard deviation in practice. Okay, moving on to more, we're going to look at now symmetry. So if a distribution is symmetric, it will look like that, or it could even be rectangular, it could even be triangular, or anything that is symmetric. You can be able to fold it together and it will meet, so a mirror image. If you have asymmetry, so something that looks like this, where you have skewedness, or like this, then you have asymmetric distributions. Okay, so how do you know? Well, you plot the data, or you might know the shape is symmetric or not symmetric just by based on past studies have told you that. All right, so we will look at what is called the empirical rule. The empirical rule is used when our data is normally distributed, and it's only used for normal data. So we have a normal distribution. This is the shape, it's a bell-shaped curve. And when we know that our data is normally distributed based on, say, past studies, or they just know that from expertise, then we can use this formula. If the distance from the mean is 1 standard deviation, so this is case 1, so mu plus or minus 1 standard deviation, then we have 68% of the data. So the central or middle 68% of the data will fall 1 standard deviation above and below the mean. Case 2 2 times, and these are multiplied, by the way, 2 times the standard deviation. So if we are 2 times the standard deviation above or below the mean, we will have 95% of the data, and that's going to be the middle 95%. Just like the IQR was the central or middle 50% of the data. Third case, mu plus or minus 3 times the standard deviation, we have 99.7% of the central data. So to look at a picture, see what that looks like. This first bell-shaped curve is the normal distribution, and we can see that if you look at the mean, let's say the mean is $1.26, and then if you have a standard deviation of 2 cents, then the distance above the mean would be 126 plus, so $1.26 plus 2 cents is going to give us $1.28. That's above, and below the mean would be $1.26 subtract 2 cents. That gives us $1.24. We then know that the central 68%, so you can see it all shaded in. Let's see if I can kind of get that. This central 68% is going to be between those two values. So between $1.24 and $1.28, we have 68% of the values. Okay, moving on to 2 standard deviations. So if we go 1 plus, or $1.26 plus 2 times 2 cents, right? That's going to be adding 4 cents. So that's going to be $1.26 to $1.30. We're going to be 2 standard deviations above. And same thing, if we take $1.26 and subtract 2 times 2 cents, we're going to go down to $1.22. And that is going to represent 95% of the data. I'm shading this all in. It's almost the whole, it's almost 100%, right? 95%. So it's going to be from $1.22 to $1.30 is 95% of the data. Okay, so if we were to cut that in half, let's say here, 68, if we wanted to just go between $1.26 and $1.28, that would be half of 68, which would be 34%, right? 34%. And so you can, if you can see, if we wanted to go plus or minus 3 standard deviations, we would then have 99.7%, because the empirical rule is 68, 95, 99.7% of the central or middle data. So from between $1.26 to $1.30, this half would be 40, and I get 47.5, right? Because it's 95% on from the middle, and from the middle down it would be 47.5 as well. Same thing from here, $1.26 to $1.28 is going to be 34%, and it'll be 34%. And you can also find the values from the end here. So what would be in the yellow part? Well, it would have to be the difference, right? If you have 68 in the center, then the whole thing, the whole bell has to add up to 100%. So there has to be here 16% here and 16% in here. We call these the tails. Likewise here and here, can you guess what percent we would have? That would be 2.5%. Here would be 2.5%. And those are the tails of the distribution, or the tails of the bell. Right, so you can use this empirical rule to be able to determine how much data you have between certain values, or above a certain value, below a certain value. So if you go, well, how much of the data is above $1.26? Well, it has to be 50%, because it's the mean, right? And the mean and the median of normally distributed data are equal, right? Because of the symmetry rule, right? So Let's look at an example. The time needed to assemble a particular piece of furniture with experience is normally distributed with a mean of 46 minutes. So that would be mu. And the standard deviation is equal to 3 minutes. So that would be sigma. What proportion of the assembly times are between 37 and 46 minutes? Question 2, what proportion of assembly times are more than 49 minutes? So provide a sketch to support your answer. I always start with a sketch because I find this really helps keep it straight. So I sketch what I've been given. I know that the mean is 43. And I know that the standard deviation is equal to 3. So before going on to the next video, see if you can answer these two questions. We have question 1 here and question 2 here. See if you can answer those by using the empirical rule, and then at the next video segment, I will pick up from here to go through the solution.